No, I guess we're doing video. Okay. Anyway, this is my 22-inch kiln. I guess I should have prepared a little better for this. Grab a tape here. I just casted this yesterday. This part here, which is the wall, and it has a metal liner to reinforce it during the casting process. Now I'll pull a tape on this. Yeah, the overall is .26, and the bore should be right around 18. The depth is about a little over 15, about 15 3/8. The top there. Now inside this, there will be a 1-inch thick ceramic blanket that'll line the inside, the bottom, also the top here. The lid has yet to be casted, and once it's done, then there will also be a ceramic blanket on that. And the idea of the ceramic blanket is, not only insulative qualities, but to help keep the kiln cleaner. I may put a coating on that, I don't know yet. But the hinges are just kind of temped on. I just have them tacked, so to speak, and I'll have to slot these holes to allow the lid to float up. I made this out of a pressure water tank, a pretty large one. I don't know, it was a gift. The cart is also a gift. The ceramic liner, the refractory, is fire brick that I get in a barrels at a time of it, remnants of new brick that's cut-offs from a company that builds wood stoves. And I grind it through a grinder into a smaller powdery type material, and then add some, what I used is C-Car 71 to it as the binder, which is about, I think it's 5% by volume. And then, of course, it's a green format, called like a green brick. Now this is all tamped. I tamped this very, very hard with a 2x6 as I multiply filled it. That's why I built this. I built a mini cement mixer. Grab a light here. I don't know if you can see it right there, to assist me in the process of mixing the refractory and the binder agent thoroughly. So I tossed it all dry in the cement mixer and then let it run for several minutes to mix it up thoroughly, and then added water to that. I added water to a consistency of when you squeeze it, grab a handful of it, squeeze it and release your hand, it would hold a form. Okay, but not so wet that the water would run out of it, so to speak. Which is kind of hard to do, I found out. It's not easy to keep it just exactly the same. So it might have some lineation or stratification. I don't know until I get that liner out, and that's the next challenge, is to remove this liner, which I probably two options that I'm considering. One is to weld some pads in here with eyelets on each side, maybe 90 degrees apart, and put a turnbuckle, and then tighten the turnbuckle and compress this down to break it loose. I wrapped the metal liner with a plastic material, which is, so we can get you a decent shot of that, right here, as a film. So this would break off of the refractory or clear the refractory easier. I don't know, we'll see how that goes. It should be fine, but we'll just have to see. Then again, when I remove it, it might break the refractory too, I don't know. But one thing I like about this is if I decide that I don't like the casting when I remove the liner, All I have to do is repulverize this material and I can reuse it. So it's like recycling, if you will. Now, later, as things progress, this section over on this side of the unit, because you notice the kiln is offset on the cart, there will be a structure come up to mount all the electronics to control the kiln. And at the same time, right down in here, I'll be mounting a small little hoist on a cantilever beam arrangement. Art supplied me with some photographs of a cantilever beam that turned out became very helpful and useful, even though I had ideas of what I wanted to do, but those photographs basically brought it home for me. So that will be installed, and the idea of that will, in this arrangement, there will be a vacuum pump also built into this platform. And the idea of that is it'll all be self-contained as a unit, have the controls to control the kiln during its runs, as well as when it's done, to be able to pluck the mirror blank out of the kiln. And I'll have it'll be on that where the cantilever beam comes in, the hoist, and it'll have a vacuum cup that'll suck onto the surface of the mirror, in theory, and we'll see how that goes, and to extract the blank out of the kiln, and then I'll be able to swing it over to a table that'll be sitting in here to set the blank on the table, and then from there to the grinder polisher machine to be squared up and then ground. But now there's been talk of and I've been in on the discussion a little bit, of making a rotating platform. Now, Art wanted me to supply some artwork relating to that, and I actually haven't really drawn any up. The idea is I'll penetrate right through the center of the kiln, and I'll be using probably a 309 or a 316L stainless steel shaft, large diameter, large cross section. Not so much because it's holding weight, it's because of the temperatures it's operating in. I want to keep it rigid enough to support what I'll be doing in here, and the table will set into that, or bolt into it, or key into it, and that table will turn, and that shaft will penetrate down through the kiln into the structure down below, and which this will be opened up, and there'll be an air bearing, a magnetic coupler, or a magnetic bearing coupler arrangement. I haven't decided yet. I'm looking at maybe a combination of the two, and then a DC motor with a controller to control the RPM. And I'm thinking very seriously about using an Arduino microprocessor to be able to program writes code to cycle in RPM, and that way I can look at the rotation through the top, because there'll be a small inspection hole. I may even set up a quartz window and put a video cam in, not in, but around the kiln, so I can review that by video. And then I can see how things are transpiring when it's rotating. We're not talking a lot of RPM. Probably maximum that I'll ever do would probably be in the 20 RPM range, and anything from 20 on down, to pull in the curve, centrifugally throw the curve in, if you will. But that's the concept. It's a basic idea. It's a basic system. We don't need bearings, I don't think, inside the kiln, because then you're getting into such as ceramic bearings and such. I think you want to keep things as isolated as much as possible to get as clean and smooth a rotation, vibration free, because otherwise that vibration, those oscillations, will be transferred into the glass, as the glass, once it takes a flash point, and whatever is oscillating is going to be locked in to the glass. It may not be a problem. It can be just ground out. I don't know. But I thought it's not that big a deal to develop for my kiln, that type of process. And I have my concepts and my ideas. Other folks have theirs, and I wish them all the luck in the world. I hope theirs works out for them. But I have my path that I'm going to follow. And the guys on on the group are extremely helpful, and I do appreciate everything that they're saying and doing. I appreciate the responses as far as discussion. Sometimes I get a little bit irate, and I apologize for that. I don't mean to be that way. I just, I guess maybe I'm getting to be an old fart and set in my ways, like a lot of us get. But at any rate, that's the project. There's still a long ways to go with this. And once the casting's completed and I get things lined out, I can get it cleaned up, get it painted. It'll look a lot more presentable aesthetically. That's, to me, it's just aesthetics, but that's an important thing too. But now to inject a note, this kiln is very heavy, and I don't know if it's necessarily all the water content in the refractory, but the refractory is fairly heavy. There was probably about 5 gallons of water used for all of the castings that I've done so far, the bottom casting and the cylindrical casting. And that's going to be the next step, is getting that dried out, and it's going to take some time. I'm going to do it very gradually. As soon as the sun gets more up here in my neck of the woods, a kiln will be placed outside with maybe a breeze to help dry it out some. And eventually I'll get the coil set up in it and do some slow ramping and hold periods, soak periods, to drive the moisture out of the refractory. It'll still be in a green state, and then once I'm satisfied that the moisture content is low enough, then I'll ramp the temperatures up all the way up to a full burn, just to see what I can get out of the kiln. I'm shooting for 1050 Celsius, mainly because that's what my pyrometer is set up to do, or my thermocouple. And if I can achieve that, and I have a lot of latitude for higher temperatures, because it is going to be a very heat efficient kiln, I'll upgrade to a better thermocouple, and we'll see what the peak operating temperatures. Maybe I can get up into that full cone 10 range, or 2350 I think is what Arch mentioned with the big kiln, that 30-incher he got. So we'll see. And this thing may end up being a total flop. I don't know. We're going to find out. But I'm going to hang in there and keep being persistent with it and try to make it work. So anyway, that's it for today. And today is April 14th, 2012. And it's in the afternoon. Other than that, boy, I love being retired. That's all I have to say for now. I'll do an upgrade or an update later as things progress. Thanks, guys.